Hey scientists, it's Brian,
And Alyssa.
and welcome back to another demo of the week.
This week, we're going to be talking about the electromagnetic spectrum.
In any given atom, electrons reside in what we call orbitals.
Now, we can excite these electrons, they will gain energy and move up to an orbital of a higher energy level.
But how do we excite these electrons? Do we throw them a party?
No, silly. If we add heat to these electrons, they will gain enough energy to move up an atomic orbital.
Oh, okay, so don't electrons want to be in their lowest state orbital?
That's right. So, in nature, everything wants to be in their lowest energy state. So, eventually, the electrons will relax back into their ground state, and in this process, they will emit a light particle, which we call a photon.
The energy of the photon release is equal to the energy difference between atomic orbitals. Elements can have vastly different energy orbitals, so that means these photons that are released will also have different wavelengths. Some wavelengths reside in the visible light spectrum. However, most wavelengths cannot be observed by the human eye.
For example, when our coats interact with light, they reflect a wavelength that corresponds to the color we call blue.
So, however, if you go to a doctor's office and get an x-ray of your leg, that would happen without you even seeing the x-ray, but there's pictures.
Oh, okay. So each photon has a specific wavelength that corresponds to the amount of energy it has. And if we can see the photon, then we know that it's on the visible spectrum and we can calculate its wavelength based off the color we see.
That's right, Alyssa. How are we going to demonstrate that idea?
Well, I have several solutions here filled with metal ions, since metals have a lot of electrons. When we spray them over a Bunsen burner, this will excite the electrons, and we might be able to see them release their photons to get back to ground state.
Oh, that's awesome. Let's try it. Whoa, that was cool. Why were the metals so many different colors?
Well, each metal is different, so the energy gap between orbitals is different as well.
That is really cool.
I know, right? I can't wait to try this with every metal I can find.
Well, hold on a second. Not all metals will react the same way. Some metals can be really dangerous to burn. Additionally, some metals will also not emit light in the visible spectrum, so that means we can't even see it.
Oh, okay. I guess this means I'm not going to try this at home. And you scientists shouldn't either.
Well, I guess that's it. Thanks for watching.
We'll see you guys next time for another Demo of the Week.